Yeah, hi everyone, Mr. Markwick here. Today I'm going to show you a video working out quartiles, measures of spread, and outliers using a formula. I'm going to start with outliers here on the left-hand side. I'm going to show you how to work out the five-figure summary. Before I do that, let's talk about quartiles. As the name suggests, quartiles basically splits up a set of data into 4 quarters. So with our quartiles, we've actually got a Q1, all right, and the Q1 mark, anything below the Q1 is the bottom 25% of the data. The Q2 is the median. We've spoken about this in a previous video. The median, or Q2, is the middle value of the set of data when ordered. Anything below Q2 is the bottom 50%. Anything above Q2 is the top 50%. Q3 represents the 75% mark, so anything above that is the top 25% of the data. We can also talk about, between Q1 and Q3 is the middle 50% of the data. We'll talk about that more when we look at the IQR, or Interquartile Range. But before we do get to that, I'm going to show you how to work out the five-figure summary here. Now, five-figure summary is important, especially when you're comparing 2 sets of data. And it's pretty handy because it helps you draw a box plot. Now, box plot, I've got a video about box plot, but to be able to draw a box plot or a box and whisker plot, you need a five-figure summary. So today, that's what we're focusing on, the skill of actually coming up with or determining the five-figure summary. So the 5 figures are, I've got them here, the minimum value, the lower quartile, the median, upper quartile, and the maximum value. And I've got 2 sets of data here that I'm going to show you how to work out those 5 figures. You can probably already see that the minimum and the maximum are pretty easy to work out. Here's your minimum for this set of data, 2. And here's your maximum, 18. Like I said, I've already ordered this set of data, so it's there from lowest to highest. Minimum, maximum, pretty straightforward. The next number I'm going to show is actually the median, so Q2, which is the middle value, or the middle number. Now, I've got an even number of data here in this first example, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So, one way of working out the middle value in a set of data is work out how many numbers you got. In this case, I've got 10, add 1, that's 11, and divide that by 2. So 11 divided by 2 is actually 5.5 or 5.5. So my median lies in between the 5th and 6th value. So 1, 2, 3, 4, 5, it's halfway between the 5th and 6th value. So it's actually the average of those 2 values. So 6 and 8. So 6 plus 8 is 14. 14 divided by 2 is 7. So my median, or my Q2 value, is 7. All right. Now, what I'm going to do to work out the Q1 value is look at the bottom half of the data. So we're looking at this half of the data now. And the bottom half, I've got to find the middle value in the bottom half, and that's my Q1. So in this set of data, I've got 1, 2, 3, 4, 5 numbers in the bottom half. So my third number is 1, 2, 3. Is my Q1 value. So Q1, which is 4. Okay, and then in my top half of the data here, I'm looking at the third number there. So 1, 2, 3, which is 13. So my Q3 value is 13. So there you go, my 5-figure summary. Minimum 2, Q1, 4, Q2, 7, Q3, 13, and maximum 18. Okay, so that's how you work out 5-figure summary for an even set of data. Okay. Now here, the second example I've got, there's an odd number of data. So you count here 1, 2, 3, 4, 5, 6, 7, 8, 9. Slightly different. First of all, minimum. It's pretty easy. 1.6. Maximum, 2.9. My middle value, like I said, I have 9 numbers. So again, to work out the middle number, how many numbers have you got? 9. Add 1, that's 10. 10 divided by 2, 1, 2, 3, 4, 5. My 5th value is my middle value. So this is my Q2, 2.1. Now, this is really important. This is different from when we have an even set of data. When we're working out the Q1 value, we're only looking at the lower half of the data, not including the median value. So we're only looking at those bottom 4 numbers. Okay, so the middle of those bottom 4 numbers is actually in between 1.7 and 1.9. So it's the average of those two numbers. So 1.7 plus 1.9 divided by 2 is actually 1.8. So my Q1 value is 1.8, halfway in between 1.7 and 1.9. Now, to work out my Q3, again, I'm looking at the top half, not including the median value. So I'm just looking at those top four numbers. And again, it's going to be halfway in between second and third number. So halfway in between 2.4 and 2.7, which for me, my Q3 is 2.55. So the five-figure summary for this set of data, and this is an odd set of data, okay, my minimum value 1.6, Q1 1.8, Q2 2.1, Q3 2.55, and my maximum is 2.9. Okay, guys, so that's how you work out a five-figure summary, looking at an odd or even, set of data. Okay, next thing we're going to do is we're going to look at measures of spread, and in particular, we're going to look at two ways of measuring the spread of data, or how spread data is. And this is good when we're comparing data, talking about consistency of data in particular and things like that. So the two methods we're going to use, we're going to work out range and we're going to work out the interquartile range. Let's start with a range. Now the range is simply the maximum value, take away the minimum value. So while I'm looking at this example here, this example right here, my maximum is 18, my minimum is 1, so my range, as we said, is the maximum minus the minimum value. In this case, 18 minus 1, which is 17. So the range of that data is 17, okay? Now, the interquartile range is actually, it says here, the upper quartile minus the lower quartile. And shorthand way of writing interquartile range is IQR. And shorthand way of writing upper quartile is Q3, lower quartile Q1. So IQR is equal to Q3 take Q1. So what we need to do now is actually work out Q3 and Q1. Before I do that, I'll work out Q2 because I want to get the middle value out of the way first. So how many numbers have I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 plus 1 is 14. 14 divided by 2 is 7. So my seventh value, 1, 2, 3, 4, 5, 6, 7, is my median value. That's my Q2 right there. Okay, and now to work out my Q1. Now remember, because it's an odd set of data, I'm not going to count that Q2. I'm only looking at these numbers here. Whoops. Excuse me. I'm only looking at these numbers here. And to find the middle number. So out of those 1, 2, 3, 4, 5, 6 numbers, my median falls halfway between those two. So the average of 2 and 2 is still 2. So my Q1 value is 2. And my Q3 value, again, I'm not including that median number. I'm just looking at those top 6 numbers. In this instance, it's halfway between 5 and 6. Average of 5 and 6 is 5.5. So my Q3 value is 5.5. Okay, so there you have it. The interquartile range, let's do that down here. So IQR is equal to Q3 minus Q1. For these examples, Q3 is 5.5 and Q1 is 2. So my interquartile range is 3.5. Again, when we're working out range and interquartile range, it's good for comparing data when you're particularly looking for consistency in data. So the greater the number, or the greater the range of the interquartile range, the more spread the data is, the smaller those values are, the more consistent the data is. Okay, so something to keep in mind when you're comparing two sets of data and you're looking at things like range and interquartile range. Now, last thing I'm going to do here is look at outliers. An outlier is essentially a number that doesn't belong, a number that's far too small or far too big for a set of data, but it's included in the data anyway. And there's two formulas that we use to work out if a number is an outlier. Looking at this set of data here, you can probably already see there's a number there that doesn't belong. But what we're going to do is we're going to go through the process and actually determine whether it is or it isn't an outlier based on the formula. Okay. Sometimes numbers you might think, geez, they might just be on the edge. I don't know if it is an outlier. That's why these formulas come in really handy. So there's two instances. It can be too small. In this case, it's less than Q1 minus 1.5 times by the interquartile range, or it can be too big. So for example, it's greater than Q3 plus 1.5 times by the interquartile range. So they're the formulas we use to determine if a number is in fact an outlier. So let's work with the lower end here first. So let's see if there's a number that's less than Q1 take 1.5 times by the IQR. Let's rewrite that formula. Is there a number in there that's less than Q1 take away 1.5 times by the interquartile range? We know that Q1 is 2. We know that the interquartile range was 3.5. Okay, and I've done this one on a calculator already. That equals minus 3.25. So is there a number in this set of data that is less than minus 3.25? Minus 3.25. No, there's not. So no number's less than minus 3.25. So there's no outlier on the lower end. Let's work out if there's a outlier on the upper end. So let's use this second formula here. So is there a number that's greater than Q3 plus 1.5 times by the interquartile range? Okay, and again, Q3 for us is 5.5 plus 1.5 times by 3.5, which was the interquartile range. I've done that one on a calculator, and the answer there is 10.75. And you can see that the number 18 here is actually, there is only one number, but there's one number that's greater than the interquartile range. So you can see that 18 is greater than 10.75. Therefore, 18 is an outlier. Okay, and we'll talk about in the next video what we do with outliers when we're dealing with five-figure summaries and how to include those on box plots. But that's for another time. Just for today in my class, we're looking at those three things: quartiles, measure of spread, and outliers. Again, the questions are up on Daymap. If you're working from home, please, if you don't understand, get in contact. But yeah, use this, guys, as a blueprint. You know, watch it over, pause it when you need to, and have a go. And yeah, thanks for watching.